Welcome to October 8th LeetCode Challenge. Make the string great. Given a string S of a lower and uppercase English letters, a good string is a string which does not have two adjacent characters S index I and S index I plus 1, where I is greater than or equal to 0 and less than or equal to the length of string minus 2. The ith index of string is a lowercase letter, and S at index I plus 1 is the same letter but uppercase, or vice versa. To make a string good, you can choose the two adjacent characters and make the string bad, then remove them. If you can keep doing this until the string becomes good, return the string after making it good. It is guaranteed the answer to be unique under the given constraints. Notice that an empty string is also good. So, for instance, we have the following string here, and we want to make this a good string. So basically, you want to take I index 1 as such, or 2, and then we just basically make it good, which is removing the characters, the lowercase and uppercase letter to remove those two, and then we just get the lowercase LeetCode right here. Similarly, if we were to make a string good here, we can remove, let's say, B, right? Making it A, capital A, C, capital C. And then from there, we could just either remove C or A, the pairs, I should say, lowercase and uppercase. Then we just get an empty, or an empty string, which is also good. If the string only has one letter, then lowercase only, then we can't remove it because it needs to be an uppercase and a lowercase pair. So the constraint says length of S is between 1 to 100, and S contains only English, lowercase and uppercase English letters. So it's kind of about solving this. So my intuition comes to this is basically solving this using one iteration, basically using a stack. Let's suppose that we find a pair in step I in the iteration. So say if we find a pair, right, like uppercase and lowercase. So in one iteration, it means that the characters S at index I and S at index I minus 1 I should say, make a pair. So therefore, or plus 1 I should say, we could ignore the pair index S at index I and remove S at index I minus 1 from the end of a good string. Otherwise, you would just add S at index I at the good end of the string. So basically, what we do is store all the previously visited characters in the stack. Then the operations on the stack is equal to the operation in the previous string, and we just basically execute the stack. So the first thing we should do is initialize an empty stack. So say we have the following. So we're going to use the stack to store the visited characters. So stack. There you go. The next thing you want to do is iterate through the characters S. So for current character in the list of string S, we are going to check if the current character makes a pair in the last character in the stack. Then we can remove both of them. Otherwise, the current character is we add the current character to the stack. So F stack and the absolute ordinal value of the current character. So we use the ordinary value because minus the ordinary value of ordinate of the stack, the last character of the stack, is equal to 32. The reason why we do this is because the ordinate value between the uppercase and lowercase letter is the difference between uppercase and lowercase letter in ASCII ordinate value is 32. If that's the case, then we pop it from the stack. So stack.pop. Otherwise, else what we could do is append the current stack dot append the current character. Alright, that seems pretty straightforward. And then at the end of this, we want to basically return our solution, which is the string joining of the stack. So return the string concatenated by all the characters left in the stack. So we basically perform all the operations inside on the stack, and then we just execute it right here. So this is solving it using a stack. Okay, awesome. So time complexity, so if we say n to be the size of the length of s, the string s, then time complexity will go n because we need to iterate through the current characters in the list of s. So each step basically we just remove a character each time, therefore overall time complexity is big O of n. Space complexity, we use a stack and we store all the characters we encounter inside the stack, so we pop the character after we find one. So basically, worst case scenario is big O of n is stored inside the stack, where time complexity overall is big O of n. So yeah, time complexity and space complexity is big O of n, and we use a stack to basically store the operations that we remove from the string s. Alright, have a great day, guys.